Hello everybody, I'm Glaucia Botelho from Federal University of Rio de Janeiro, and today I will present part of my master research work. I will follow this agenda. Firstly, I will contextualize where the research is sourced, and then present our proposal coined as LigADOS. I would like to start talking about the open data movement. This movement has been guided by the need to comply with laws to enforce transparency and also enforce accountability, and establish the need to make public sector activities data available to citizens and society in general. Although this data can be available in several ways on the web, the access to open data fosters the use of platforms to support data portals development and deployment. So, open data platforms are used to construct open government data portals, as these examples here. The problem is that in open data platforms, datasets are usually described by metadata with poor semantics. Moreover, they may remain data silos with no explicit connection or data integration mechanisms, making it difficult for the user to locate and interrelate relevant data sources. So, this slide just to clarify how data are exposed in an open data portal developed using CCAN. We can see here a CCAN instance that represents the portal with a sort of published datasets. Each dataset is made available to the public by their distributions. The distributions is where the data are. And in parallel, we have the Semantic Web available. The Semantic Web offers the fundamentals to interconnect information resources across the web, making it machine processable and taking the benefits of semantic annotations by the use of vocabularies and ontology, whatever, which means that data are accompanied by richer descriptors. Also, resources can be explored by searching, querying, and navigation. And among the technologies utilized, we can mention the Resource Description Framework, or simply RDF, which structures the data in triples. In this sense, it's possible to mention the FAIR initiative. FAIR is an acronym for Findable, Accessible, Interoperable, and Reusable. It's an initiative that recommends a set of guiding principles to make data generated and/or used by scientific research easier to be discovered, accessible, interoperable, and reusable by both people and machines. It's initially focused on research data, but it has been adapted to all types of data. FAIR 10 data points is the FDP is part of the FAIR initiative. So FAIR data points are the materialization of some of the guiding principles aimed to improve data discoverability and accessibility by people and machines. And they actually constitute metadata repositories. Here we can see how an FTP is organized. It has 5 layers of metadata organization. The 5 layers are the FTP metadata that represents level 1, followed by data catalog metadata, dataset metadata, and distribution metadata. Finally, the data records metadata that represents level 5. This structure here, composed by catalog, dataset, and distribution, represents the portal organization structure as we have seen before. And the data records metadata is represented with this triple here, which means that a dataset distribution makes reference to a vocabulary, for example. It has a hierarchy from high level less granular to bottom level more granular, and it moves towards better dataset findability as metadata more detailed at each level to better understand the data content without the need of access the data instance. In this context, we can talk about open data interlinkage. It's about to aggregate value to data. Data interlinkage is the fundamental principle of linked open data. The links can be used to describe, associate, and infer new knowledge and support navigation and exploration. Based in this scenario, our objective is to develop an approach that allows to identify semantic interlinkages between datasets modeled in RDF, published at open data portals constructed by using open data platforms. and by this to contribute with richer access possibilities, exploring linked data capabilities for searching, querying, and navigation. So, to achieve this objective, we develop an approach coined as LigADOS. LigADOS aims to take advantage of the benefits offered by Semantic Web to interlink datasets published in open data portals, generate higher-grained semantic metadata, as well as provide support for machine processing. So, we propose to combine open data portal platforms and Semantic Web technology to provide the understanding of plenty of interrelations among the published datasets. We develop an interlinkation process, but I don't have time to explain here in details now, so I will explain it by an application. In short, LigADOS reads all RDF dataset distribution published in an open data portal in order to identify the triple subjects and objects that are identified by a URI, and that are annotated with some vocabulary, ontology, thesaurus. This is an example of a context of a RDF dataset distribution. In this example, the objectives resources of two triples are annotated using terms defined in the Agravoc thesaurus, as we can see here, highlighted. Glyphosate was annotated with C24849 term, and imidacloprid was annotated with another term. Thus, the approach takes these thesaurus terms and triggers federated queries to find the class or concept that categorizes the terms, used to annotate a triple resource in an RDF dataset distribution. To identify the class or concept, LigADOS considers the element exactly one level above, looking for relations such as class brother, RDF type, or subclass of. In this example, both highlighted objects of triples have been annotated with agrochemicals concept that represents a concept one level higher than this highlighted. LigADOS will generate a new graph, coined the graph of semantic interlinks, containing, among others, triples like this, a dataset distribution, reference a vocabulary class concept. This is a result of the approach. This distribution dataset references is noted here, agrochemicals, and the generated triples is shown here. Let's see how it will work in a portal. The distribution way on from dataset A, which has a triple that has been annotated with some term of vocab V, and LigADOS identified the class 1 as one higher level classification of the term utilized to annotate a triple. It means that class 1 represents a metadata of a record. In the same way, we can see here the distribution 3 from dataset B, which has a triple that has been annotated with some term of vocab V, and whose class 1 represents one higher level classification of the term utilized. So the approach is based on data instance semantic classifications that are higher level of semantic descriptors from the annotated triples. LigADOS generates a source of metadata. Data records metadata more expressive than a dataset metadata level. And we coined this kind of interlinkage as interactive dataset interlinkage. Interlinkage is possible by the use of the same class of vocabulary. Applying LigADOS to more than one portal, and when we have this kind of situation here with two or more open data portals with a graph of semantic interlinks, and a central point harvests them, compose a source of metadata repository, we have a fair data point structure. Let's see how it works in an FDP. Its catalog represents one open data portal. We apply LigADOS to both catalogs X and Y. The FDP harvests metadata from them, getting together all of them in the same repository. Then, access data record metadata. It's possible to get indirect dataset interlinkation between open data portals. We have developed a prototype and we carried out an experiment using datasets from the Brazilian Open Data Portal. It was a portal developed using CCAN. The LigADOS approach was applied to a subset of the datasets extracted from this portal. This is the graph of semantic interlinks that was generated by LigADOS and published in the portal instance. So, LigADOS makes available the interlinkage to the general public as well as application programs. These nodes represent dataset distributions. These nodes represent the vocabulary utilized to annotate triples from datasets distributions. And this represents data records and metadata. Both datasets distributions share concepts in common from Agrovoctesaurus, that is rainforest, vegetation, scrub, and tropical forest. The blue highlighted arrows show the dataset distributions interlinks through the common thesaurus concepts, and the red highlighted arrows show the interlink through Agrovoctesaurus. The main aspect observed is that the new interlinkation points are considering the data instance, namely the semantic meaning resulting from the use of the same vocabulary, ontology, thesaurus, whatever, and not just free terms attributed by the publisher by the time of dataset publication at the portal instance. So, our approach interconnects published datasets exposing existing non-explicit interconnections among them. LigADOS supplies semantic metadata to compose 4 of 5 metadata schemas levels of an FDP, a fair data point, especially the data records metadata level, which expands the dataset interlinkages possibilities between data portals. And as a future work, we intend to use graph centrality measures to identify most popular classes and or concepts from which we can generate subgraphs. We understand that it's necessary because the graph of semantic interlink is becoming higher and higher and maybe causing a sort of confusion to choose a start point to exploration. And we understand that it's needed to execute more experiments, even include users' validation. These are the main references we utilized. It's all. Thanks a lot for your attention.